Algebra 1. This is a review of lessons 9.1 through 9.5. So here's how this is going to work. I have 6 problems that I want to step through, and you have, I guess, basically 2 options. Option 1, you can work through these problems as I work through them. You can write them down exactly as I write them down. You can basically just copy what I do and submit that. Or if you feel like that'll take longer than what you want to take, you can just see me write down the problem. Then you can do it yourself. If you feel like you can do that, this is a little bit more the preferred way because it'll do a little bit more to test to see how you're doing with these problems. So you can see me write down the original problem. You can try to do it yourself. You can skip ahead later in the video to where I'm wrapping up solving the problem, and you can make sure that you got the problem correct. Jump on to the next problem. Once I've written it down, you can write it down, see if you can do it on yourself, skip ahead in the video, and then get those 6 problems done that way. So any flavor of anything like the above is fine. I figured, well, we've been away from this material for a couple of weeks, and some of you are kind of sketchy with it to begin with. So I'm working on grading the homework. I spent a while today just downloading all of the PDFs and photographs that you emailed me, and then getting them sorted by, well, I had PDFs and photos and documents and Google Docs for biology and history and math. So I downloaded all like roughly 250 attachments that I had in the email. I got them sorted by class. I got all the Algebra 1 attachments all together, and then I got them organized as, for the most part, usually one PDF per student. So like who's top in the class. So like Tim's lesson 1, lesson 2, lesson 3, etc. Although I think he emailed me one that had them in order to begin with. Anyway, so yeah, I got all that done today, and then one of the first things I'm doing tomorrow is I'm jumping into grading. So you'll be getting feedback on how you did here pretty quickly. But I figured we would need a little bit of review. So that's what this is looking like. So your assignment is by Friday to submit to me these 6 problems. Either you do them yourself or you just copy down what I do and you submit that. And submitting will be done through Google Classroom. I would like a PDF preferably. There are a couple apps that I've had, well, one in particular that I've used for several of my college classes, Tiny Scanner, and it does a great job. It uses your smartphone's camera. You hold it up over your document, your paper, whatever, and you take a picture within the app, and it does a fantastic job of converting it to a PDF with a nice white background and dark text, and you can adjust the contrast a little bit. And if you took the picture at a little bit of an angle, it unskews it for you, and then you can even say like add page to then flip your math paper over and take a picture of the second page, and it makes it page 1 and page 2 of a PDF. That would be my top choice. My second choice would be for you to take pictures, just like regular pictures, and then to insert those into a Word document, a Google Sheets, not Google Sheets, that's a Google Doc, and to submit a document. But top choice would be PDF. Okay, all right. Let me know if you have any questions about any of that, but let's go ahead and jump into these problems. So, one that would be like from lesson 1. So again, this is Algebra 1. Oh, hold on a second. I need that. Okay. I'm sorry. I usually don't have this problem. I'm too close to that button right there, and it's throwing stuff off. I'm too close to the top of this window. Algebra 1. And this is review of 9.1 to 9.5. All right, so here's the first problem. Let's graph y equals negative x squared plus 4x minus 3 using the axis of symmetry vertex and y-intercept. Okay, so we want to find these three things. Now you might recall the axis of symmetry. We have an equation that is x equals negative b over 2a. And that x equals, that is the x value of the axis of symmetry. It also graphs a line, a vertical line, straight up and down, vertical line, is negative b over 2a. Now, what that entails, though, is we need to know what a and b are at this point. And you might recall that a is what's attached to the x squared, b is what's attached to the x, and c is what is by itself. So what we have is a is negative 1, because it's a negative 1 x squared, b is 4, and c is negative 3. Okay, so if we want this axis of symmetry, then what we have is x equals negative b, so that's a negative 4, over 2a, a is negative 1. So that gives us, I need to make this pen just a little bit smaller. Hold on a second. I'm using it at a width of 3 and I want a width of 2. Okay, let's make that a little bit smaller. There we go. So we have negative 4 over negative 2, because the 2 times negative 1, negative 2, so negative 4 over negative 2. Negative over negative, the negatives cancel, so we have just 2. So we have x equals 2. So we have x equals 2 there. And so what that tells us is that when we go to graph this, I'm just going to make this really small for now, just over here. We'll do a bigger graph in a second. So we have our x-axis here. We have our y-axis. We get to an x value of 2. This vertical line, this acts as the mirror, where one half of the parabola is on the left side, the other half of the parabola is on the right-hand side. Okay, so that's our axis of symmetry. Let's look next at the vertex. I'm going to change my color here. Let's go with, what do I want to go with here? Let's go with this darker yellow. We'll give that a try. All right, so the vertex. The vertex is a point somewhere on this axis of symmetry. So somewhere on that axis of symmetry is where the point that is either the top of the parabola or the bottom of the parabola. Okay? And so we know that it has the same x value as the axis of symmetry because it's somewhere on that line. So the vertex, we know, has an x value of 2, and what we don't know yet is the y value. So we find the y value by plugging the x value in for x in our equation and seeing what we get for the y value, because y equals stuff on the right-hand side. So what we know is y equals negative 2 squared plus 4 times 2 minus 3. And notice it is a negative, the negative is outside, so it's going to stay around. So we get negative 4 plus 4 times 2 is 8 minus 3. So we get negative 4 negative 4 plus 8, that is 4. 4 minus 3 is 1. So what we know now is the vertex is the point 2, 1. Okay, so we know that piece of information as well. And then finally, we want the y-intercept. Now, the nice thing is we know that the y-intercept is just y equals c. Because what's the y-intercept? It's where the graph crosses the y-axis. The x value, when you're on the y-axis, okay, the x value is 0. So if you look at our original equation, if we plugged in 0 for the x's, all that we're left with is this -3. In other words, that's the y value when x is 0. That's the y value where we're crossing the y-axis. So what we have is y equals -3. That is our y-intercept. So we put all these pieces together, and I'm going to erase this here. I'm going to do one a little bit bigger, a little bit cleaner for us to do. I'm going to go black here, and we have our axes, arrowheads, x-axis label, y-axis label at an x value of 2. We have this vertical line. That's our axis of symmetry. We have the vertex at 2, 1. So at 2, 1, we have our vertex right there. And then we have our y-intercept of -3. So I'm going to go on the y-axis down to -1, -2, -3. On the y-axis at -3. That's my intercept. And then I do a parabola shape where the parabola, where the like basin, or where the rounded part of the parabola goes through the vertex here. So it's going to curve like this, and it's going to get steeper, and it's going to go like that. And then I just try to make it look like a mirror image on the other side, something kind of like that. And that is our graph of, what was it, y equals -x squared plus 4x minus 3. Now, one thing you might recall from lesson 3 is the negative out front. The -x squared is a vertical reflection, and that makes it so our parabola is upside down. If we had a positive x squared, it would be right side up. -x squared, upside down. Okay, so that is that problem. Moving on to the second problem that I have for us. Problem number, oops, I want black, sorry. Problem number 2 is what are the roots of, I'm just going to do a sketch of a little graph here for you. And it's going to be this parabola here. I'm going to say that's that, so that's 1, and that's -1. All right, so what are the roots? And this is just to check to make sure that you recall the terminology or the idea that the roots of the equation, we also call them the zeros of a function. The roots or zeros are the x values where the graph crosses the x-axis. So where does this one cross the x-axis? It crosses it at -1 and at 1. Those are our two roots. If a graph crosses the x-axis twice, it has two real roots. If a parabola just barely touches the x-axis just at one point, it's one double root. You might recall that. But then if it doesn't cross the axis, like if it's somewhere like up here, we would say it still has two roots. All parabolas have two roots. It's just a matter if they have two different real roots, if they have one real double root, or in this case, they would have two complex or two imaginary roots. Okay, so that's that one. Nice and quick and hopefully easy. Moving on. Number 3 here. Let's describe how g of x equals -3x squared plus 2 is related to f of x equals x squared. All right, so f of x equals x squared, that's our parent function, and we want to know how is the parent function, how is this a standard parabola that goes through the origin, that has this vertex at the origin, how is it affected by the different parts of the graph? So what do we have going on here? We have a negative, we have a 3 there that is being multiplied by the x squared, and let me grab this one, and let's add blue back in there, and make it 2. And we have this plus 2. Okay, so what we have going on is the negative in front of the x squared. We mentioned this earlier with number 1. If I scroll up a little bit, we mentioned that earlier with the negative x squared that was going on there. A negative attached to the x squared is a vertical reflection. That's what's going on there. And then the 3. So what happens is when you take whatever x is and you square it and then you multiply it by 3, you create bigger y values. And the effect that that has is it has as if you grabbed the parabola and you stretched it vertically to make it taller and narrower. And the term that we use for that is it is vertically stretched or expanded. I hear both. I'm going to go with expanded. Vertically expanded. By a factor of 3. And then that plus 2, it shifts the parabola up and down. So we could say it is translated vertically up 2 units. When you deal with vertical, plus 2 moves it up. So we put these pieces together, and you don't have, the question didn't ask you to do this, but if we did a little sketch of what this parabola would look like, we know it's shifted up 2 units, and it's stretched, or it's vertically expanded, so it's going to be narrower, and it's vertical reflection, that's fine. And it is, so it's going to be up 2 and upside down because of the vertical reflection, and a lot narrower. So I'm going to go with something kind of like that. Again, x-axis, y-axis. Okay, so that's what would be going on. Hopefully that makes sense. Hopefully that lesson went well. I need to add another page here. Insert new pages, just in case. Let's add 2 more pages. Okay, moving on to page 2. Here's our next problem. So that's that. All right, this is what, number 4? Yeah, that was number 3. Number 4. Solve by completing the square. Here's what we want to solve. We want to solve x squared. Oops, sorry, that's a squared. X squared minus 6x plus 2 equals 0. All right, so completing the square. That's where we create the situation on the left-hand side that allows us to go from 3 terms, where there's an x squared, an x to the first, and then a constant, to factor that down to being a binomial like x plus 2 or x minus 3 squared. And then we're able to go from there. So the first thing that we do is I'll even kind of jot down the steps here. I'll jot those down in blue. 1, move the constant to the And I'm going to do this narrower. Move the constant to the right-hand side. So here's what that's going to look like. That's going to look like x squared minus 6x. Instead of plus 2 equals 0, we're going to subtract 2 from both sides to give us equals negative 2. Okay, step 2. Add to both sides. We want to add to both sides. We want to add a b over 2 squared. So b is our negative 6 there. So we want to do x squared minus 6x plus negative 6 over 2 squared equals negative 2 plus negative 6 over 2 squared. Okay. I can add here and simplify. Then simplify. Okay, so we could do, well, simplify the right-hand side. We don't care about simplifying the left-hand side because of what we're just about to do. So what is this? Negative 6 over 2 is negative 3. When we square a negative 3, we get 9. So this is the same thing as x squared minus 6x plus, now I'll just go and say negative 3 squared equals negative 2 plus 9. So what does that gives us? That gives us x squared minus 6x plus negative 3 squared equals negative 2 plus 9 is 7. Okay, now step 3. Factor the left-hand side. Because the left-hand side, again, we have created to be a perfect square. And how does this factor? It factors to be this b over 2. So it factors to be x plus b over 2 squared. That's what it factors to be like. And that's why I didn't bother simplifying this, because I'm just about to, what seems almost kind of like magically, get rid of it, but I'm just about to use it, and I like to keep that negative 3 visible. So I'm going to factor this like x minus 3 squared equals 7. Now, oftentimes what comes up at this point is the question of like, well, wait, Mr. French, what happened to the other x? You had an x squared, and there were two x's. There was this x term and this x term. And now there's only one x term. It's like, well, if you took this step, if you took this step and multiplied it out, it would take you back to this. Because x minus 3 squared is x minus 3 times another x minus 3. So what do we get here? When we FOIL this, we have x times x is x squared. X times negative 3 is negative 3x. But then we have this negative 3 times x. That's another negative 3x. So how many total x's do we have? We have negative 6x. And then negative 3 times negative 3 is a positive 9. And what's this? Negative 3 squared. That's the same thing as negative 3 times negative 3. So we have the exact same thing. We've just changed what it looks like. Okay, next, step 4. Take square root of both sides. So when we do that, we get, when we take the square root of anything squared, we're just left with what was being squared. So we're just left with this x minus 3 and equals plus or minus the square root of 7. We need that plus or minus. Whenever you're taking the square root of something that has the unknown squared, whenever the unknown is being squared and you take the square root, you need that plus or minus. And I'll spare you the explanation because we've talked about that a few times. And then finally, just finish solving for x. So 5, finish, solving for x. So what do we need to do here? We need to add 3 to both sides. So that gives us x equals 3 plus or minus the square root of 7. Now the square root of 7, it's a decimal that goes on forever. So this is the best that we can get. There's no more simplifying that we can do. Now usually with these I ask the students to use a calculator and to get what the approximations of this are. So you could say x is approximately, if we did the 3 minus root 7, I like to do the minus first because it's a smaller value. So if we did on my calculator 3 minus the square root of 7, I get approximately 0.35. It's approximately 0.35. And then if I do the x, or the 3 plus root 7, 3 plus root 7, I get x is approximately 5.65. 5.65. So those are my two approximations. Okay? That is that problem. That's number 4. And then number 5, yeah, I think I have enough space here. Number 5, solve using the quadratic formula. Solve using the quadratic formula. And here's what we want to solve. We want to solve x squared minus 5x equals 7. Okay, so you might recall the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. That's just something we're going to need to memorize if you have not memorized it yet. Where a, b, and c are the values that I get from the formula, but that's assuming that the formula is in standard form, which would be ax squared plus bx plus c equals 0. So we need equals 0. So I need to rewrite this first to be x squared minus 5x minus 7 equals 0. And now I can identify that a is 1, b is negative 5, and c is negative 7. I always recommend start out just writing what a, b, and c are. That way you don't have to think about it at all, and those values are right there for you. Now we can plug in that info to our formula. So that gives me x equals negative, what's b, negative 5, plus or minus the square root of that negative 5 squared minus 4 times 1 times c, which is negative 7 times negative 7. That square root covers all of that. And then all of that over 2a, which is 2 times 1. Now we just do some calculator work. Well, a negative 5, that's just 5. We have plus or minus, and let's see what all this inside the square root comes to be. So negative 5 squared, that's 25, because negative 5 times negative 5 is 25. And then I have negative 4 times 1 times negative 7. Well, that's the same thing as 4 times 7, so that's 28. So plus 28, all of that over 2. 25 plus 28, 25 plus 28 is 53. So that gives me 5 plus or minus the square root of 53 over 2. And I don't think the square root of 53 can simplify. So what I look for to see if I can simplify a square root, I look to see is 4 a factor, or so that's because that's 2 squared. Is 3 squared or 9 a factor? is 4 squared or 16, is 5 squared or 25, or any of these squares, 2 squared, 3 squared, 4 squared, 5 squared, or any of them a factor of 53. So like I do 53 divided by 4. Nope, I get a decimal. 53 divided by 9. Nope, I get a decimal. And so you look at it like that. I knew I could stop there because when I did 53 divided by 9, well, I know that 9 squared is 81. Well, that's not how I started to explain it, and then I suddenly switched how I was explaining it. When I did 53 divided by 9, I got something smaller than 9, and I already checked the one perfect square, 4, which is smaller than 9, and so I knew that I could stop checking for anything. Well, because 53 is, well, 7 squared is 49, so it's like just something just a little bit bigger than 7. So once you've checked a perfect square bigger than 7, then, and if it doesn't come out, then that's it. So this is the best that we can do with simplifying that. There's no more, oops, there's no more simplifying that we can do. What we can do is we can approximate just like the other one. So if it helps, you can view this as 5 over 2 plus or minus the square root of 53 over 2. Because keep in mind, when you add fractions that have the same denominator, the denominator stays. And so like the 5 halves plus or minus root 53 over 2 would simplify to that if it helps for approximating. So this is x equals again. So if I did the x is approximately, so if I did the 5 halves minus, because I like to do the minus first, so I'm going to do 5 divided by 2 minus square root of 53 divided by 2. And I get about negative 1.14. Negative 1.14. And then if I do the plus 5 halves plus square root of 53 divided by 2. Oops, I actually did the divided by 2 inside the square root. It needs to be outside. So let me do that again. 5 halves plus root 53 divided by 2. And we get 6.14. 6.14. So those are the decimal approximations. In other words, if you were to graph y equals x squared minus 5x minus 7, that parabola would cross the x-axis at these values. It would cross the x-axis at about negative 1.14, so negative 1.1, and if you 1, 2, 3, 4, 5, 6, like just past 6 is where it would cross the x-axis. So however far down it would go, that would tell you that. Well, we know that it would cross the y-axis at negative 7, so it'd be way down there, negative 7. So this would like scoop down like that and then go, but I'm a little bit skewed. But just a quick visual of what's going on there. Okay, one more real quick one. This is number, what, 7, 6? Number 6. Number 6. And it says use the discriminant to identify the number and nature of the roots of x squared plus 4x plus 5 equals 0. So the discriminant is the b squared minus 4ac that is inside of the square root. It's this thing here, that b squared minus 4ac. So let me do that in yellow. So the discriminant is that b squared minus 4ac. So let's list what we know for our values again. A here is 1, b is 4, c is 5. So if we plug those in, our discriminant is 4 squared minus 4 times 1 times 5. So that's 16 minus 20, or negative 4. My discriminant is negative 4. So what does that mean? What does that tell us? Well, the discriminant, b squared minus 4ac, is what's inside the square root. So if I scroll back up to my quadratic formula. Well, square root of a negative number, that gives us imaginary values. You'll learn more about that later. So what we know is that if our discriminant, b squared minus 4ac, if it's less than 0, then what we have is we have two imaginary roots, because we have a negative inside that square root, and that gives us imaginary value. So we're doing plus some imaginary value and minus some imaginary value. If b squared minus 4ac equals 0, we'll back up to my formula again. What's inside the square root is 0, so what we have is negative b plus 0 and negative b minus 0, which are both the same thing. So what that gives us is it gives us one real double root. And then finally, if the b squared minus 4ac is greater than 0, so what's inside the square root is some real number. We have negative b plus something and negative b minus something. What that gives us, it gives us two distinct real roots. So which one of these we have? We have the negative. So our answer is we have two imaginary roots, which graphically speaking, that is a parabola that somewhere up here, it does not cross the x-axis. It doesn't touch the x-axis. And so that's what we have. So those are the 6 problems. And yeah, either copy down, or if you did on your own, either way, submit preferably via a PDF to the Google Classroom assignment by the end of Friday. And that's that. Hopefully that'll be a good start to review. We'll do a little bit more review early next week, and then next week you'll have your Chapter 9 Part A test, and we'll get going on Chapter 10. No, sorry, a little bit of Chapter 9 Part B. All right, hope you're doing well, and I'll talk to you guys later.